is AP Calculus, Lesson 2-6. We are talking about the trigonometric chain rule. And I can never say trigonometric unless I say it really fast. Trigonometric. Okay, I guess I can say it slow. But I always say trig because then I always can say it. And now you can too. All right, so let's take the derivative of these three things. You need to know all of them. These three things, giant star, you just have to memorize them. The proof for them is kind of fun. I don't have time for it, unfortunately. Unless you finish the homework early, then I can go through it. It would be kind of fun. All right, so these are the three rules. Number one, the derivative with respect to x of some constant number times sine of the inner. This always turns into that same number out front times cosine of the inner. So sine changes to cosine. And then remember, I'm only writing the doubter here. Always remember you're always multiplying by, there are two always there, weren't there? Always remember you're always multiplying by your dinner. So u prime. I'm going to do that in green. Don't forget about dinner. Second rule, out of the three rules, there are three of them. The derivative with respect to x of some constant times cosine, we'll say use our inner. That turns into, any guesses?
Sine.
Good guess, yeah, and it is sine, but something happens. So there's the a, and there's a negative. Yeah, derivative of a cosine is sine, and always remember you're still multiplying by dinner. I'm only writing the doubter for you. Yeah, so negative a sine, u. You might think that these are easy to remember, but once we start going backwards, you're going to forget these and mix them up. So try to get these really nailed down. Derivative with respect to x of a times, what's our last one?
Tangent.
There it is, tangent of our inner. Okay, you could guess all you want. I'm going to, unless you've seen it before, you're probably not going to get it. It's a times secant squared of the inner. And don't forget about dinner. I'll do that in green as well. I don't know if we've seen this before, but let me write this on the side notes in case you haven't. When I write secant squared of u, that's the same thing as writing secant of u, all of that squared. It's just the notation that mathematicians use. It is pretty annoying. It annoyed me at first, but I've gotten used to it. Same thing if I have sine squared of u, you do sine of u and then square it. So order of operations are a little bit backwards, it feels. But yeah, so this is how you write secant, or this is how you would calculate secant squared. That's how you think about it. Questions up to here. So now that you know these, let's apply them in the chain rule. So I'm going to go to the next slide here. All right. Yeah, I totally abandoned questions. That's okay. I think we kind of got sick of it anyway. Examples.
Questions are just kind of, the only thing it does is rephrase it.
Which studies show it does help, but there has to be a waiting period, a cooling off period. The derivative with respect to x, and I'm going to choose 2 times sine of 3x. All right, let's do this one together. I'll let you do number 2 and 3 by yourselves. These 3 examples, and we're done with the notes. All right, so 2 would be our a, so that's going to stay the same. So I'm going to leave that 2 there. Derivative of sine is, have you memorized it yet?
Cosine.
Cosine. And then leave the inner. Don't touch the inner, not yet. Now, I'm going to multiply by dinner. So what is dinner? 3. So this simplifies to 6 cosine of 3x. I want to back up because there is a little trick that you can remember which one goes to which, like how to take the derivative. When you're going forwards, when you're taking the derivative, you're not going backwards, you're not taking the integral. When you're going forward, this letter here, S, I think of that as same. I think of this C as change. So if you're wondering what sign to go to, If you're going forwards, S means same. It's the same sign. If it was a positive, it stays positive. If it was a negative, make sure it stays negative. Cosine, when you're taking the derivative, make sure you're going forwards. Change means you're changing the sign. So look at that letter. Think how Mr. Sindel thinks. That will help you remember. Or you could just blatantly memorize it. It's up to you. It's just a tool in your tool belt now. Number 2, the derivative with respect to x, d dx of this giant beast, negative cosine, it's not really that giant, of negative x, nested parentheses, just like Ben likes.
But no joke, I write with nested parentheses sometimes in English.
It happens, yeah. All right, do this one by yourselves and come back to me in a few minutes. Did you get it, Arrow?
I got something.
All right, that's good. Ben, how are you doing?
Good.
All right, who wants to share?
Negative sine of negative x.
Arrow, what do you think?
Yes, correct.
Correct, yeah. So the derivative of negative cosine is going to be a positive sign, but this negative comes from the dinner. So I'm going to write this all out for the notes just in case other people are watching this too. So what happened here was the derivative of negative cosine is, so C, change, is going to be a sine of negative x. That's the derivative of negative cosine of negative x. That's doubter. Then dinner, derivative of negative x is negative 1. So our final answer is negative sine of negative x. Perfect. And finally, number 3, the derivative with respect to x. Our last example for our notes. I'm going to do, I want a dinner inner. Let's do this one. 4 times tan of natural log of x. What does that turn into? And I want this simplified as one expression. Sure. Can you walk me through this step by step? Who wants to go for it?
You want me to do it?
Sure.
So first you do the derivative of the outer, which is 4 secant squared, and then the inner.
Inner is just natural log of x. Okay.
And then you multiply that by the derivative of the inner, which is 1 over x. And the inner is 1.
Perfect. And then simplified, Arrow, can you just give me this simplified?
4 secant squared times the inner, which is natural log of x over x.
Correct. Yep, there it is. Did you box your final answer? That helps, Mr. Sindel, especially when your work is messy. But if it's neat, I can probably still find it. But boxing is nice. Any questions?
So it's all over x?
All over x, yep.
I did 4 over x.
Forever.
And then multiplied the 4 and the x.
Okay.
And the 1 over x.
So you left it as 2 expressions, whereas like this 4 over x times secant blah, blah, blah.
Oh.
Like that?
So all I have to do is extend the line.
Yes.
Yes, that would solve it. Yep, perfect. All right, any questions? That concludes the notes.